Welcome to Lesson 3, Example 4, and it is asking what is the total deflection of the the 4x14 beam in Example 1, and I've got to draw Example 1 up there again. Assuming that the beam supports plaster, does it meet the UBC criteria? So I guess first what I would want to take a look at is what is the UBC criteria? I think this was 22 foot real quick. Let me double check. Yes, a span of 22 foot. So let's call it L equals 22 foot. And I guess first let's look at the UBC criteria. What exactly does it say? And it says for live load only. So live load, let's do UBC. This will be in the Uniform Building Code. Live load only. It says L over 360. And then for dead loads plus live load, you can have, I believe, L over 240. And these are in inches, just so you know. When you see L over 360, you're going to know L is in inches. But I don't have the UBC, so I'm just taking this from I do not have the UBC with me. I'm taking it from the study guide. Alright, so we want to, this is deflection. I don't know how much they've explained this in the study guide, but L over 360, usually you're going to get this with beams, and it's deflection. And it needs to be less than L. That's your kind of your maximum deflection. And this, it's going to be your deflection at your middle is typically going to be your max if you have a uniform distributed load on your beam. So that is delta max, which is your max deflection. So that's your delta max. And then that cannot be, let's say if you have a 10-foot beam, and so what would be 120 divided by 360 is 1/3. So you couldn't have more than a 1/3 inch. 0.33 inch would be your max for live load only, L over 360. Alright, so that's just a quick overview of what exactly that means in case they didn't do a sufficient job. Of course, I'll do more videos on this in the future, but right now we're just going to solve this equation and solve this problem. Alright, well, we need to go back and we need to either take a look at the reactions, and you know what? I'm just going to go back and figure this out real quick using our answers from Example 1. And we just used WL squared over. Okay, let's just go ahead and do it again. I don't like just leaving something and saying it is what it is. Let's figure it out. And then M live load equals WL squared over 8. And let's say M total load equals WL squared over 8. Now all remember is you have 100 pounds per foot. Now you can do PLF and whatever you want to do. Times 22 foot squared over 8. Your live load is going to be the same, so let's go ahead and calculate that out. 100 times 22 squared divided by 8 is 6,000, and that is familiar. And that's in foot pounds. Daddy. And remember that. Daddy. 14. And then we have 6,050 for the live load as well. And then we combine them and you have, well, remember it's going to be double, so we'll just go ahead and write it out. 200 pounds per foot. 22 foot squared over 8. That's the worst line I've ever seen in my life. Alright, and we should have, what, 100 foot-pounds. And remember, this is since it's including live load, it's going to be at 1.25 capacity. Alright, so there we were. That was what we got from answer 1, from example 1. We also want to figure out, well, we need to figure out what deflection is going to be, and that is what equals, and it's a distributed load, so if you use those equations, it is 5 WL to the fourth over 384 EI. I think that equation's on, it's definitely in your steelbook, and that's where I get all my equations like this to tell you if you have a distributed load, then that is your deflection for distributed loads. And then you want to go ahead and put that in. And remember, we had this, so we're going to do live load only. Let's see what we get for live load only. So we have deflection. Let's go ahead and change colors or something right here. Let's go to this yellow color. And we have deflection live load equals 5. W is 100. L is 22 foot. But actually, what we want to do is go ahead and change this to inches. So let's do this. Because the E is PSI. I is usually I to the 4, so let's change this to inches. This is 100 pounds per foot. We want to change that 1 foot over 12 inches. That'll give us W equals what, 100 times, or 100 divided by 12, and then we go L to the fourth, which is 22 foot times 12 inches. Oh, Liam's helping me out here. He pushed a button a little bit, so Liam's my 2-year-old. Inches over foot. All right. And then we want to say fourth divided by 384. And I guess we haven't really defined E or I yet, but we can get those using this timber stuff. You can go ahead and get that from the tables on pages. I think it's in the UBC is where they get it, but the pages 44, you can look at those tables, and it looks like on E we're going to get 1.8 million PSI. We are at number 1 and better, and it's smaller than 5 by 5. So let me look again. Yes, it's 1.8 million. So 800,000, and that's in PSI. And then if you look at the table on page 45, you get, we're using a 4 by 14 beam, is what it says right here. Remember, 4 by 14 beam has an I. Remember, we're doing about the XX. Yeah, I is right. 678.5. 678.5 inches to the fourth. EI, that's right. Yes. Okay, and we'll go ahead and solve for this. And this, remember, this is live load only. So we're gonna. This is our what we want to stay under. But we do the math, and if you calculate all that out, and remember, we can look at the units, but we're canceling out these feet. So we're 8 pounds per inch, and then we're going to cancel out this. This is a foot sign, so we're canceling that foot, we're going inches to the fourth, and that means, as we had inches, pounds divided by inches, so that gives rid of one of these inches. We have inches to the third, and then we have inches or pounds per inch squared, so that'll be coming out with inches. This is pounds times inches to the third, and this is, it's kind of confusing. Just do it yourself, and if you're not convinced, it comes out to be inches. All right, and I got 0.208 inches. And that, let's look over L over 600, and our live load allowable deflection. Let's say, wow, this is allowable. equals L over 360. And then let's look at here. L is 22 foot times 12 inches per foot divided by 360. Divided by 360. And we get 0.73 inches. Alright, so as you can see, the allowable is 0.73. We're only at 0.21 inches, so we're good. I'll just go ahead and sometimes I just do good for live load, or let's do live load deflection, which I would do good for. Alright, now we want to go ahead and I'll change colors again, and we're going to say deflection, dead load, plus live load. And then we're going to go ahead and do the equation, which is going to be 5. You have 200 pounds per foot times 1 foot. And this is just changing the units to match what we want to use. And 22 foot times 12 inches per foot to the 4th. And then this is all over. Oh gosh, that was ugly. That was very ugly. 384, 1,800,000 PSI, and then 678.5. Because those are all the same again. The only real difference, so if you look at just, it will be double this number right here. But let's go ahead and work the math just to make sure that my assumption is correct. It should be double because everything is exactly the same except for your load. So we have 5 times 200 divided by 12 times parentheses 22 times 12 to the 4th divided by 384 divided by 1,800,123 zeros divided by 678.5, and we get 0.863 inches. You could look up there and say, oh, well, we're over. No, actually, remember that over here, dead load plus live load from the Uniform Building Code says that is L over 360, and that's your allowable deflection. You want to be at least under that. That's your max deflection, however you want to call it. And so I'll just go write it down here and say, we'll call it total load. Let's call it total load. That's less writing. Anyways, is what? L over 240. And that's L is 22 foot times, 12 inches per foot. I'm not going to write it out this time. But it's divided by 240. And you get the allowable deflection of 240 is 1.1 inches. And this is greater than 0.863 inches, which equals your actual. So you are also good for. All right. And there you go. Let's look back and see if we answered everything they're asking for. It says, what is the total deflection of a 4x4 beam? We have this and said that. We said the total deflection is 0.83. There you go. And then it also asks, is it good for plaster? And we said that plaster, here was your plaster from the Uniform Building Code. And it said the live load had to be less than L over 360. And L over 360 was, where did we put that? L over 360 was this. And our dead load was this, so it was less. And then we went over to live load, dead load plus live load. And it required L over 240 for dead load plus live load, which was this. And we were less than. This was our actual dead load plus live load deflection. So we are also good. And we'll see you on the next video.